Hi students, good evening. Welcome to this video session. I remain Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall discuss your section 6.7 homework. Section 6.7 deals with using a normal distribution to approximate a binomial distribution. We are going to use a normal distribution to approximate a binomial distribution. It is recommended that you review the notes and videos in these topics prior to viewing this video. Usually we use technology to do this, videos like this. We use my calculator and Pearson StatCrunch. However, we are going to be using only my calculator in this video because StatCrunch will not do it for you for the questions we shall cover in this section. If you have to use StatCrunch, then you would have to first of all apply the continuity correction. You have to apply the continuity correction first before you can use StatCrunch. So, but we're gonna use my calculator to just do it right away because I already I wrote the codes applying the continuity correction. So let's get started. We are going to pull up, let me pull up my website as this question is loading. Okay, we can begin here until Firefox is ready. So question 1, it says here, the value given below is discrete. Use the continuity correction and describe the region of the normal distribution that corresponds to the indicated probability. Probability of fewer than 5 passengers. Fewer than 5 passengers who do not show up for a flight. So the fewer than 5 is less than 5. Okay, that's what it means. Fewer than 5 passengers, which means less than 5 passengers. X is 5, but you're looking at fewer than 5, fewer than less than x equal to 5. So you have to apply the continuity correction, and when you do that, it should be area to the left of 5 minus 0.5. So you do 5 minus 0.5 because we're looking at the less than, which is to the left. So 5 minus 0.5 is 4.5, and then this would be area to the left of 4.5. Okay, area to the left of 4.5. Question 2, if NP is this is the sample size times the probability of success, is greater than or equal to 5, and NQ, which is sample size times the probability of failure, is greater than or equal to 5. Estimate the probability of fewer than 5 if the sample size is 13 and the probability of success is 0.5. by using the normal distribution as an approximation to the binomial distribution. If NP is less than 5 or NQ is less than 5, then state that the normal approximation is not suitable. So if they ask questions like this, they want us to verify first that that the requirements are met. The requirements for using a normal distribution to approximate a binomial distribution, they want us to verify that the requirements are met before we now solve it. So I'm going to go ahead, open up my calculator. I'm going to go to here. I'm going to type in my website, www.chukwuemekasamuel.com. This is a mobile-friendly site, chukwuemekasamuel.com. Then I'll click on portfolios, and I'm going to get the probability distribution calculator. So this is the calculator we'll be using. And then here I will look for normal distribution. I'll look for normal distribution here. So we're going to look for normal distribution to approximate binomial distribution. And these are the requirements here. These are the requirements. NP, n times p should be greater than or equal to 5, and n times q should be greater than or equal to 5. So let's see how we can place this side by side with the I'm just gonna close this. Let's see how we can place this side by side with this. So that way we could see it side by side. We want to, you know what, I'm just gonna look, I'm gonna place this in place this here and see if I can do this here. So I just copied the URL, the link, and I would like to place this side by side with this question, so that way okay. For some reason I think this is trying to act up now. Minimize this, maximize, and I want it okay, there you go, this is what I want here. All right, let's see if I can actually do it this way, so that way it's better. I apologize for the extra time, but I want to do it side by side so it's easier for me. And this is normal distribution, and we want to go to normal distribution to approximate this. There you go. Thank you for holding on. Okay, now let's go ahead and verify this. We're gonna go to normal distribution to approximate binomial distribution, and they want, if the requirements are met, they want us to find the probability. So I'm gonna use this one here, the second one here, fewer than 5. So sample size n is 13 and p is 0.5. Actually, you can kind of look at this. The mean is n times p. Okay, so let's do n times p. 13 times 0.5 will give us 6.5. 13 times 5 is 65. So 13 times 0.5 is 6.5. And 6.5 is greater than or equal to 5. Then q is also 0.5. 1, because q is 1 minus p. 1 minus 0.5. and that is 0.5. So 0.5 times 13 is 6.5. So we're good. Yes. So let's go ahead and find this now. Probability less than. You click here, less than x equal to 5. Okay. Calculate. So yeah, the mean is 6.5, as you can see. Is greater than or equal to 5. So the answer here to 4 decimal places will be 0.1335. Okay. Question 3. Let's verify this. 11 times 0.4 is 4.4. N times P. N times P. 11 times 0.4 will give you 4.4. 11 times 4 is 44. So 0.4 times 11 will give you 4.4, which is less than 5. So you cannot use the normal distribution in this case. You cannot. Question 4. 13 times 0.5. Yeah, so this one works. So it's still the same thing, but I will suggest, if you're using my calculator, after doing each one, refresh the browser. So refresh the browser entirely. Refresh it. Don't click. If you reset it, if you click reset, then it resets this, but the answers are still there. So just refresh the browser. Then we can use probability at least 10. Okay, so the next one, N is 13 and P is 0.5. At least 10. So you put at least x equal to 10. I can press enter. So to 3 decimal places, this will be 0.048. 0.048. Okay. Question 5. Use a normal approximation to find the probability of the indicated number of voters. So let me go ahead and refresh this while I read this. Use a normal approximation to find the probability of the indicated number of voters. In this case, assume that 175 eligible voters aged 18 to 24 are randomly selected. Suppose a previous study showed that among eligible voters aged 18 to 24, 22% of them voted. Okay, so what is the probability that fewer than 43 of 175 eligible voters voted? So in this case, we're gonna still use this here. The sample size here is the 175 voters. The probability of success is 22%, which is 0.22. 0.22. And we are looking at fewer than 43, okay, of 175 eligible voters. So you come here, select less than, x equal to 43. Calculate. So this answer to 4 decimal places, the probability would be 0.7673. Okay. Question 6. We want to, it's the same question, is the same wording, so which I read in question 5. So I don't need to read it again. But the question here asks, find the probability that exactly 48 of 199 eligible voters voted. So let me refresh this. Yeah, we always need to refresh it after each calculation so that we don't get confused with the answers. So in this case, n is 199. That's the sample size. The probability of success is 22%, which is 0.22. And here we're looking at exactly 48 voted. So exactly x equal to 48. Enter. So to 4 decimal places, the probability would be 0.0526. 0.0526. Okay. Refresh this. Question 7. A scientist conducted a hybridization experiment using peas with green pods and yellow pods. He crossed peas in such a way that 25%, or 144, of the 576 offspring peas were expected to have yellow pods. Instead of getting 144 peas with yellow pods, he obtained 147. Assume that the rate of 25% is correct. Question A. Find the probability that among the 576 offspring peas, exactly 147 have yellow pods. So we'll come here. Excuse me. Here the sample size is 576. The probability of success is 25%, which is 0.25. And then this is already in exactly, so that's fine. Exactly 147. Okay. So our answer is 0.0368 to 4 decimal places. 0.0368. Then the next one is probability that at least 147. So I don't need to refresh. I don't need to refresh because it's the same question. It's the same basic question. It's just a second part of the question. Second part of the main question. So I just select at least and I click calculate. So why I usually refresh is so I don't have the previous answers, but because this is parts of the same question, it's fine. Okay. So the answer to the B part would be 0.4052. Okay. Which one is useful for determining whether the claimed rate is incorrect? So with probability, we learned that if the probability of an event is less than 5%, the event is likely unusual. So the event is, we say the event is unusual. So if you look at this here, the first probability is less than 5%. Is actually 3.68%. Second probability is 40.52%. It's way greater than 5%. So the B part is better, part B. Okay. Is there strong evidence to suggest that the rate of 25% is incorrect? No, there's no strong evidence to do that. No. Okay, next question is, they just changed the numbers, but it's basically the same main question. They just changed the numbers. So I'll refresh this. Then here our n in this question was 560. P would be 25%, which is 0.25, and they're asking us for exactly. So exactly x equal to 143. And the probability is 0.0373. That is to 4 decimal places. 0.0373. Then at least, I just select at least, calculate. The probability is 0.4052. And of course, part B is useful for that. Is there strong evidence to suggest that the rate of 25% is incorrect? No. Question 9. The probability of flu symptoms for a person not receiving any treatment is 0.026. In a clinical trial of a common drug used to lower cholesterol, 23 of 801 people treated 23 of 801 people treated experienced flu symptoms. Assuming the drug has no effect on the likelihood of flu symptoms, estimate the probability that at least 23 people experience flu symptoms. What do these results suggest about flu symptoms as an adverse reaction to the drug? So here, before we do all these questions, make sure that the conditions are met. Okay, make sure that these requirements are met before you attempt any question. Why I'm doing it is because I assume that they have all been met, but I want you to verify. For them to ask this, they didn't have an option. Normal distribution cannot be used. You know, the ones we did earlier where they had that option, that normal distribution, where they had that second option, we really had to verify. But these ones, because they didn't have that option, we assume that already the requirements are met. However, if you're taking this in a traditional classroom, you have to verify first that the requirements are met. Okay. So for this question, our N is 801. Our P is 0.026. Then we have at least 23. X equal to 23. Calculate. So this is a 0.3557. Okay. What does the result from part A suggest? With this here, this is 35.57%. It's way more than 5%. So, and we assume the drug has no effect on the likelihood of flu symptoms. So this result actually supports that. Okay, so the drug has no effect on flu symptoms because that's the probability of what we found, and this is more than 5%. So we say the drug has no effect on flu symptoms because x greater than or equal to 23 is not highly unlikely. Okay, it's not highly unlikely, so our option will be A. Question 10. A gender selection technique is designed to increase the likelihood that a baby will be a girl. In the results of the gender selection technique, 880 births consisted of 447 baby girls and 433 baby boys. In analyzing these results, assume that boys and girls are equally likely. So by that assumption that boys and girls are equally likely, that means that P will be 0.5. Okay, that the probability of success is 0.5. A, find the probability of getting exactly 447 girls in 880 bets. So we'll come here. The sample size here is 880. The probability of success is 0.5 because they say equally likely. And we're looking for exactly x equal to 447. Okay. So that gives us, to 4 decimal places, the probability is 0.0241. 0.0241. Okay. Then B, find the probability of getting 447 or more girls in 880 bets. So 447 or more means at least 447. So I get at least x equal to 447. And that gives us 0.32996. So this will be 0.3300. Okay. I'll just say 0.33 because it says round to 4 decimal places as needed. So you can actually say 0.33. It's still fine. Okay. Because of as needed. C, if boys and girls are equally likely, is 447 girls in 880 bets unusually high? So let's look at these options. They told us here in the question that 880 bets consisting of 447 baby girls and 433 baby boys. And boys and girls are equally likely. So if you look at this 880, you look at it, it's not really far from what is expected. Out of 880, you have 447, and the probability says that the boys and girls are equally likely. So the answer would be no, it's not far from expected, given the probability of having a girl or a boy. Okay, it's not unusually high, no, because 447, the probability is 50-50. Okay, 50% chance, equally likely, which means 50-50. So and out of 880 bets, you have 447 girls. Okay, so it's 50-50. It's not unusually high, no. So that's the way you actually look at this question here. Half of 880 is 440. So having 447 girls is not far from what is expected. So our correct option would be D. Okay. Then C, what probability is relevant for trying to determine whether the technique is effective? Is it the result from part A or the result from part B? We want the result from part B because we want the probability of the result that is at least as extreme as the one obtained. So the correct option here would be C. Okay. D, based on the results, does it appear that the gender selection technique is effective? I think it does not. It's more like random chance. No, because the probability of having 447 or more girls is not unlikely. Because if you look at this here, probability of having 447 or more girls is 0.33. That's 33%, which is greater than 5%. 5%, if we have anything less than 5%, is highly unlikely. But 33% is greater than 5%, so it's more of a chance. I would say no, because the probability of having 447 or more girls in 880 beds is not unlikely, it's not. So for B, you eliminate it because it says likely. It says it's unlikely. Unlikely means the probability is less than 5%. So you eliminate B and you eliminate D because it says it's unlikely. Okay. Now you look at A and C. With A and C, it's not unlikely, and if it's not unlikely, it's more of a random chance. Okay, so you can't say it is not attributable to random chance. It is attributable to random chance. So the correct option, the correct option would be A. Okay. Let me refresh this. Question 11. Assume 40% of us have group O blood. I wouldn't put of us. Anyway, well, assume 40% of people have group O blood. A hospital is conducting a blood drive because its supply of group O blood is low, and it needs at least 188 donors of group O blood. If 493 volunteers donate blood, estimate the probability that the number with group O blood is at least 188. Is the pool of 493 volunteers likely to be sufficient? So we use this calculator as usual. Sample size here is 493. Probability of success is 40%, which is 0.4. You convert it to decimal, okay? And we are looking at least x equal to 188. So the probability to 4 decimal places would be 0.813. 0.8133. Okay. What does the result from part A suggest? This is greater than 5%. It's more than well, in this case they talked about 50%, okay, because of sufficient. So I want you to kind of to see the difference. We've been talking about unlikely and likely. So if it's 5%, it demarcates whether the event is likely or unlikely. But here they're talking about sufficient. So sufficient would be like majority. Okay, is it enough? So we are looking at 50%. So if you look at this now, the probability is 81.33%. So it's more than 50%. So you eliminate A. Because it says not likely to be sufficient. No, it's likely to be sufficient because it's more than 88, because it is more than 50%. So you eliminate A, C, and D, and the correct option would be B. Question 12. In a survey of 1,006 people, 702 people said they voted in a recent presidential election. Voting records show that 67% of eligible voters actually did vote. Given that 67% of eligible voters actually did vote, find the probability that among 1,006 randomly selected voters, at least 702 people actually did vote. What do the results from Part A suggest? So we use this again. Sample size here is 1,006. Probability of success is 67%, which is 0.67. And we are looking at least x equal to 702. So to 4 decimal places, our answer would be 0.0329. 0.0329. Okay. And this is actually less than 5%. This is 3.29%. 3.29%, which is less than 5%. So I think some people are being less than honest because the probability is less than 5%. So I will go with B. Okay. The probability is less than 5%. So some people are being less than honest. Okay, because that probability is less than 5%. Question 13. In a study of 283,040 cell phone users, it was found that 59 developed cancer of the brain or nervous system. Assuming that cell phones have no effect, there is a 0.000273 probability of a person developing cancer of the brain or nervous system. It is therefore expected that about 78 cases of such cancer in a group of 283,040 people. Estimate the probability of 59 or fewer cases of such cancer in a group of 283,040 people. What do these results suggest about media reports that cell phones cause cancer of the brain or nervous system? So this question here, you have to be careful. They talked about expecting 78 cases, and then they say estimate the probability of 59 or fewer cases. So you just have to be careful here. But here, our sample size is 283,040. The probability is 0.000273. And less than or equal to is at most. Okay, it is at most. X equal to 59. Calculate. So here, this is 0.0217 to 4 decimal places. 0.0217. Okay. What does the result from Part A suggest about the media reports? This appears to be incorrect. Because one would expect that more than 78 cell phone users would develop cancer. In fact, the study may offer significant evidence to suggest that cell phone use decreases the probability of developing cancer. So the media reports appear to be incorrect here. Question 14. Based on a recent survey, 20% of adults in a specific country smoke. They didn't say the country though. In a survey of 60 students, it is found that 8 of them smoke. Find the probability that should be used for determining whether the 20% rate is correct for students. What can be concluded? So let's go ahead and find this. Now, with this question here, they're asking you how, of course, the sample size here is 60. Probability is 20%, which is 0.2. However, and we know x is 8, but what probability would you put in this case? I mean, look at the question here. 20% smoke. In a survey of 60 students, it is found that 8 of them smoke. So we are going to look at probability that at most 8, not at least 8. In a survey of 60 students, it is found that 8 of them smoke. Now they're asking what probability should be used for determining whether the 20% rate is correct. We're gonna use at most. Okay. I think that's the probability we should use, because if we use 20% of adults smoke in a country, that means probability is 0.2. They took a survey of 60 students. 8 were smokers. For us to see whether that 20% is correct, we're gonna find probability that at most 8. Probability that at most 8 smoke. So we're gonna use that probability to determine whether the 20% rate is correct for the students as well. So this is 0.1292. Okay, and this is 12.92%. Is a lot. The conclusion would be that the probability is not really small. If you look at here, the options, probability is not very small, probability is very small. So probability is not very small. So we eliminate B and D. Let's look at A and C. A, there is evidence against the 20% rate because this probability is not very small. C, there is not very strong evidence against the 20% rate because this probability is not very strong. So the probability is not very strong, but this is not very strong evidence against the 20% rate. Okay. Question 15, we are done with the calculations. So let me maximize this. Which of the following is not a requirement for using the normal distribution as an approximation to the binomial distribution? Okay, A is correct. B is the sample is the result of conducting several dependent trials of an experiment in which the probability of success is P. Yeah, probability of success is P, but no, the sample is not several dependent trials, so no. C is correct, and then D, sample is a simple random sample of size n, yeah, from a population in which the proportion of successes is P, or the sample is the result of conducting n independent trials. Yes, one of the requirements of a binomial distribution are independent trials of a binomial experiment in which the probability of success is P. Yeah, so the one that is not a requirement is B. Okay. 16, why must a continuity correction be used when using the normal distribution approximation for the binomial distribution? Because you're using continuous to approximate discrete. Okay, the normal distribution is continuous probability distribution being used as an approximation to the binomial distribution, which is a discrete probability distribution. So that's B. Question 17. Which statement below indicates the area to the left of 19.5 before a continuity correction is used. Left of 19.5 should be at least, it should be at least 19. Okay, it should be at least no, I'm sorry, not at least 19, because it's left. Okay, left of 19.5 should be at most 19. Now let me say this. Okay, if you had right of 19, if you had right of right of 19.5, right of 19.5 should be greater than 19. Okay, greater than 19 will be right of 19.5. Because you have 19, okay, 19 plus 0.5 is 19.5. 19 minus 0.5 is 18.5. So let me say this and you can take down. So if you have right of 18.5, it should be greater, it should be at least 19 should be right of 18.5. Right of 19.5 should be greater than 19. So at least 19 would be right of 18.5. Greater than 19 would be right of 19.5. At most 19 would be left of 19.5. Less than 19 would be left of 18.5. And then equal to 19 would be between 18.5 and 19.5. So in this case, left of 19.5 should be at most 19. At most 19, less than or equal to 19. Okay. Question 18, which is not a criterion for distinguishing between results that could easily occur by chance and those results that are highly unusual? A, X successes among n trials is an unusually low number of successes if the probability of X or fewer is very small. Okay. That is part of it. Okay. B, the sample size is less than 5% of the size of the population. No, B would not be a criterion. C, probability of an event is 5% or less. Yes, that is a criterion. D, X successes among n trials is an unusually high number of successes if the probability of X or more is very small. Yes, that is a criterion. So I will go with B. Okay. Question 19, last but not the least. A continuity correction is made to a discrete whole number X in the binomial distribution by representing the discrete whole number X by which of the following intervals? And that is this, X minus 0.5 to X plus 0.5. All right. Thank you so much, students, for listening. Let's go ahead and save this. If you have any questions, please ask. And you have a great evening.